Yes,
Today,
sir.
today we'll discuss shear strength of the soil, direct shear test, vane shear test, triaxial test. This is one chapter. Then after that, soil compaction, laboratory compaction test, maximum dry density, optimum moisture content. Till now, this way we will be studying. Okay. This is a two chapter. Here we have a two chapters. The first one is a shear strength and second one is a compaction. But I will discuss first compaction and after that I will come to shear strength. Okay. In last class we have discussed about consolidation. The consolidation means the soil is compressible. Right? The soil is compressible. Why compressible? Because when we apply load to the soil, then soil volume will be get decreased. You know? This is a three-phase system, and in this one this is air, this is water, and this is solids. Okay, when I apply some load here, the static load or dynamic load, whatever that load you apply here, when you apply the load, this volume will get decreases. This volume get decreases. When this volume get decreases, then that soil is called as a compressible soil. That material or otherwise that soil is considered as a compressible. Then to happen this compressible, that volume to decrease, we have four reasons that we have discussed in the last class. The first reason is air compresses, and the second reason is air escapes, air escapes. The third reason is water expels, water expels. The fourth reason is particle readjustment, particle readjustment. Okay, these four reasons are there. Because of these four reasons, the soil will get compressed, the volume will get decreased. Now in last class we have discussed about water expulsion. This is considered as a consolidation, primary consolidation. This, the first two is considered as initial consolidation. Yesterday I did not explain, I did not give another name for this initial consolidation. You can call this as a pre-consolidation. You can consider it as a pre-consolidation. Note it. In the last day class, you can note it. That is, this is also called as pre-consolidation or initial consolidation. Now, in this initial consolidation, what happens? The initial consolidation is also called as compaction. Okay, the term consolidation is dedicated for water. The term consolidation is dedicated for water expulsion, and the term consolidation is dedicated with the static load. If you are if you are decreasing the volume by using a static load, then I can say that is a consolidation. But this air compression and air compression and this air escape cannot be done by static load. That's why here I am using a new word. That new word is your compaction. Then in this compaction, what we are doing is we are removing air voids. We are removing air voids. We are not touching any water voids. We are removing air voids by applying dynamic load. By applying dynamic load. Then you might understand that what is the difference between consolidation and compaction. Consolidation is all about water expulsion. Compaction is all about air compression and air escape. And consolidation is with static load, and this compaction is with dynamic load. In consolidation, we discuss only clay particles. In compaction, we will discuss all particles. Even gravel, sand is also discussed in compaction. Right? Then what is the definition of compaction? Definition of compaction is expulsion of air voids by applying dynamic load. Why we are doing this one? Because to increase density. To increase density. Now see, what is the purpose of doing compaction is, compaction we are doing it to increase the density, but consolidation we are not increasing the density of the soil. Okay, of course it may increase its density, but main motto of consolidation is not to increase the density. There the main motto is to understand the behavior of the soil, understand the behavior of the soil, and understand the settlement of the soil. Okay, but in compaction we have a standard that purpose here, that is to increase the density. Okay, now look at here, this compaction is first studied by Proctor, the scientist name Proctor. Okay, what he understood is, he did one small experiment. That experiment I will first explain with the three-phase diagram, later I will explain with exact experiment. The first experiment is not this one. He considered a dry soil. Dry soil means what? You will be having this much, this is a solids, this is solids, and all air voids is filled by air. This is called as a dry soil. Now he apply the dynamic load. Dynamic load means it might be tamping, or it might be pushing, or you can call with the technical term, that is the kneading, or rolling, or vibrating. Okay, these loads, any one of these loads or combination of these loads you are applying to the soil. When you apply this load, then some of the air will be removed. Some of the air will removed. When this much of the air is removed, means obviously the this volume is decreased. You know, earlier the volume was this much, but now the volume is decreased. Now whether the mass is decreased, just check it here. Density means mass by volume. Here, by applying these forces, we have decreased the volume. Whether the mass is decreased? No, mass is not decreased. Therefore, mass remain constant, but volume decreased means automatically density will increase. Understood? We have increased the density. Then after that, here the soil will be having some voids inside, and these voids are air voids, and air entrapped will be there. That's why they will be far away from each other. And when soil is a dry state, its shear strength, shear or otherwise cohesion will be negligible. Okay, negligible. When soil is dry, then cohesion will be negligible. To increase the cohesion, I will add a little amount of water here. When I add a little water to the soil, then it will increase the cohesion of the soil particle. Means the water will go and stick to the soil particle. Therefore, it will increase the cohesion. When the cohesion is increased, what is the meaning of cohesion? That is attraction between the same particles. Attraction between the same particles will increase. Therefore, these particles will attract each other, and this volume again decreases. Now here you have to observe, I have added a little water to this one, means mass is little increased. This mass is little increased, but along with that the volume is decreased. This much of air is again expelled, therefore volume is decreased. Volume is decreased and mass is increased. These two observations I have made here, volume decreased and mass increased. I have to explain it something reverse. That is, mass increment will be more arrows, and volume increment will be less arrows in the initial condition. Okay, initial condition, volume increment, volume decrement will be with 1 arrow, and mass increment with will be more 2 arrow. Why? Because density of the air is 1.2 kg per centimeter cube, meter cube, and in density of the water is 1000 kg per meter cube. Okay, sorry for the inconvenience, sorry for the mistake. No, this is 1000 and this is 1.2. Initially we will be having like this, that is, mass increment will be with 3 arrows, then volume decrement will be with 2 arrows, then the density will increase, then it will go like this. Okay, then the later density starts decreasing. Why density starts decreasing? Because look at here, this is your solids, 4%, 8%, 12%, 16%. When it is a 20% of water you have added, Then after that, if you add further water, then it becomes 22%. Then your earlier mass was this much, and later the mass is increased. Sorry, mass is increased and volume is also increased. Then again mass is increased and volume is also increased. Now in the second phase, mass and volume is increasing because water is adding more than the saturation, and mass is increasing because water is added, therefore mass is also increasing. Both are increasing. Then what decision we have to take here? But the density is decreasing. Why density is decreasing? Because the increment of this volume will be compared to the mass will be more with the two arrows, therefore the density will decrease. That's why he got a compaction curve initially increases with water content, and then it will decreases with the water content. This is a conclusion by Proctor. This is a conclusion by Proctor. Understood? Means he has got one conclusion here from this experiment. He has got one conclusion here, that to achieve some maximum density, to achieve this maximum density, this is the maximum dry density, gamma d max, or MDD we call it is. MDD means maximum dry density. To achieve this one, you have to add a particular amount of water content, that we will call it as a OMC, that is your optimum moisture content, optimum moisture content. Then if you add more than this, then also the density decreases. If you add less than this, then also density will decrease. Okay, this conclusion is obtained by Proctor. For this one, he has done one compaction test. Okay, that test I will show you and I will explain further. Okay, now you can see this is the compaction apparatus. This is called as a compaction mold. This compaction mold, you can see there is a base plate here, and this is called as a compaction mold. From here to here is a compaction mold. The top portion is your, we will call it as a collar, or otherwise it is considered as a dolly. The top portion, it is collar. Then like that we have one mold. This mold capacity is 1000 centimeter cube, and we have another mold with a bigger dimension. This mold with a collar, but only mold dimension will be here 2250 centimeter cube. 2250 centimeter cube. Okay, the height of this mold is, 12.73 centimeter. The diameter of this mold is 10 centimeter. 10 centimeter. Here the height of the mold remains same, 12.73 centimeter. The diameter of the mold is increased to 15 centimeter. 15 centimeter. Right? We have this compare this mold and this mold. First we have to decide whether which mold I have to select for compaction. Okay, this decision I have to make. Means mold selection decision. Mold selection. You have got that there are two types of mold. There are two types of mold, but out of these two, which one I have to select? Okay, for that you have to do a small test, that is a sieve analysis. That you take a soil here, take a 4.75 mm sieve. This is 4.75 mm sieve. This soil, if it retains on this 4.75 mm more than 20%, more than 20%, and that less than that, over this much only, more than 20% of the soil is retained on 4.75 mm, then you use the bigger mold. More than 4.75 mm, 20%, more than 20% above 4.75 means what? If this soil have a gravel portions, that more than 20% gravel is there in the soil. Gravel is there in the soil. If bigger particles are there, then use the bigger mold. Understood? Now, if more than 80% of the soil is passing through, more than 80% of the soil is passing through, then you use a small mold. Understood? Okay. Don't call it as a coarse soil means big mold, fine soil means small mold. Don't use the words of coarse and fine for selection of molds. Understood? And students will be getting confusion. So they say that sir, light compaction means small mold and heavy compaction means big mold. No, this mistake don't do. Okay, light compaction and heavy compaction, they have nothing to do with the selection of mold. Means you can do light compaction in the bigger mold, heavy compaction in the bigger mold. You can also do light compaction in the lower smaller mold and heavy compaction in the smaller mold. Therefore don't answer in that way. Okay, now you got how to select a mold. How to select a mold. Okay, now we have a two hammers here. This hammer is, okay na, this hammer is a smaller hammer and this hammer weight is 2.36, 2 uh, 2.36 2.5 kg, you can consider 2.5 kg. No, this hammer weight is 2.5 kg. Now you can see here one steel rod is there inside the hammer. Then this one, if you lift it up, then it will come to this height, and from there if you drop it, then it will fall. It will fall with the height of 310 mm, 310 mm drop, 310 mm drop. Okay, na? Means you are using a smaller hammer. Small hammer 2.5 kg and 310 mm drop. This will result you, this will result low, this one, low compaction. Right? Then what about heavy compaction? For heavy compaction, you are using the bigger hammer. This hammer weighs 4.5 kg. This bigger hammer weighs 4.5 kg, and this one when you lift it and drop it, it will drop from 450 mm. It will drop from 450 mm. Understood? This is heavy compaction. Means these two will decide heavy compaction. Any doubts here? No doubt? Okay. One more specification I have to mention here. Which specification? That is number of drops. Right? Number of drops I have to decide. Okay. For each layer, okay, number of layers also I have to decide. Here I will write layers. Number of layers for light compaction is 3 layers. 3 layers. Number of layers for heavy compaction is 5 layers. 5 layers. Understood? Okay. Now number of blows. How many number of blows for light compaction and heavy compaction? Anyone? If you know it,
25.
how much?
For both 25 number of blows.
For both light compaction and heavy compaction?
Yes.
Okay. Then we have another number, no, 56. Where we will use that?
For CBRC.
Modified compaction, sir. 3
That is
layers.
CBR test.
No, CBR test is that is
Sir,
different test
modified
complete.
also use it, sir. Modified also use it, sir.
Modified compaction means heavy compaction.
Yes, sir.
Okay, for heavy compaction you want to give 56 number of blows?
Yes, sir.
No.
Then only 3 layers are used, sir. Soil.
Means where 3 layers are used, there you will give 25 number of blows.
No, sir.
Hmm.
Heavy compaction when using 5 layers, each layer 25 blows, sir.
Hmm.
When using three layers, then 56 blows for each layer, sir.
No,
Sir, yes, sir.
no, no.
Sir, I practically did an experiment on site, sir.
Yeah, you did practically, but you didn't read the IS code, I think. I will explain.
Sir,
Don't worry.
see,
Don't worry. Next, any others?
sir, here there are two types, sir.
Hmm.
25 blows for 5 layers. When using 5 layers, only use 25 blows, sir.
No, no. Hmm. Not like that. Okay. Don't worry. Why I ask this question? Because many students, even professors also, will get a doubt here where to use 25 blows and where to use 56 blows. That's why I paused here and I started asking you people. Okay, na? That's why now look at here. This 25 number of blows or 56 number of blows are not depending on number of layers, are not depending on type of compaction. Then this 56 number of blows or 25 number of blows, that is depending on, carefully, that is depending on diameter of the mold. Diameter of the mold. Why? Because see here, this hammer or this hammer, both hammer have a same diameter. You observe this one. This hammer has the same diameter and this also hammer also has the same diameter. Usually the diameter of the hammer will be 5 centimeter. This is also 5 centimeter. Then what is the difference here? The weight of the hammer is 4.5 kg here and this weight is 2.5 kg, already explained. The very interesting thing here, what we have to remember is the diameter of the bigger mold is this much and the diameter of the smaller mold is this much. Now here, if I want to evenly distribute the number of blows, then how many blows I have to do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, like that. How many number of blows I have to give so that I will get a even distribution of the load? Then the answer is 56 number of blows I have to give for even distribution. Then here, this is a small mold, but still you have a bigger, that 5 centimeter diameter. Then here if you give, then how many number of blows you have to give for the even distribution? For that answer is 25 number of blows. Now, whether you are doing it CBR, whether you are doing it light compaction, heavy compaction, that doesn't matter. 3 layers, 5 layers, that doesn't matter. That depends on the diameter of the mold. Now, I will make a table here so that you can understand very easily. This is your compaction. This is your compaction. The compaction we have two types: the light compaction, and we have heavy compaction, or you can call it the modified compaction. The modified Proctor test and standard Proctor test. Standard Proctor test, and this is a modified Proctor test. Right now, now look at here. This light compaction, what you are doing? You are doing this light compaction for, you are doing light compaction for smaller mold, small mold, that is your 1000 cc, and that you can do it for bigger mold, that is 2250 cc. When you are doing with a, then how to decide the mold? You already know that you are doing a compaction for the soil where gravel portions are more than 20%, then you will choose this mold. And you are doing the light compaction, see here, you are doing the light compaction for the soil where 80%, more than 80% of the soil is passing through 4.75, then you will choose the 1000 cc. Now look at here, you are doing light compaction, therefore I will write three terms without any that doubt. That is your 2.5 kg hammer, 310 mm drop, 310 mm drop, and 3 layers over. Okay, this is belongs to light compaction. This means light compaction. Then what about the bigger mold? You take bigger mold, or smaller mode, if you are doing a light compaction, then the same thing, 2.5 kg, then 310 mm fall, then 3 layers. See here, don't think like big mold is there, therefore 5 layers. No. Big mold is there, big hammer. No. Understood? Huh? Then after that, the diameter of the small mold is small, therefore 25 blows. And the diameter of the bigger mold is bigger, therefore it is 56 blows. Right? Huh? Any doubt here? No doubt. If you have still doubt, don't worry. I will answer that question later. Now look at here. I will come to this side. Then here also you can do this modified test by using a small mold and by using a big mold. Then the small mold means small mold or big mold, you are doing the heavy compaction, therefore it is 4.5 kg, 450 mm fall, 5 layers. See, this is heavy, therefore these all are heavy, and you are doing it in the big mold, then also 4.5 kg, 450 mm and 5 layers. Now you are doing with a small diameter mold, therefore 25 number of blows. You are doing with the big diameter mold, therefore 56 number of blows. Understood? Huh? This is your compaction specifications. If you have any doubts, you can discuss. Any doubt? Manoj?
Yes, sir.
No doubt?
Sir, no doubt, sir.
Okay. Still, if you have in your mind some doubts, then I will answer that one by using compaction energy. No? Look at here. The compaction energy, what we are giving in the light compaction and the heavy compaction. Look at it. Light compaction means the lighter energy. Light energy means small energy you are giving. Small energy you are giving. Then heavy compaction means that large energy you are giving. Then how to calculate the energy? Then energy is always force applied into distance, or otherwise drop. Force into drop. This is your energy. You know? Then now here in the light compaction you are applying which, how much force? You are applying here 2.5 kg force. This force you are applying, this force you are dropping it from 31 centimeter. This force you are dropping for 31 centimeter. How many times you are dropping it? You are dropping it by, you are dropping it 25 number of times. Right? Then this you are dropping it by 25 number of times. Then how many layers you are dropping? You are dropping it for 3 layers. Right? This is your energy and divided by capacity. The energy, the denominator will be capacity. That is your 1000 cc. 1000 centimeter cube. Now can you tell me the answer? How much it is? This is 5.8125 kg. This centimeter is there. This centimeter cancels. That is, you can write it like this: kg centimeter per centimeter cube. Don't cancel it. Okay, kg centimeter per centimeter cube. Now, very interestingly, I will go to the next slide. Look at here. This one. Here I will calculate the energy. Light compaction, I will calculate the energy. Then how to calculate? 2.5 into 31 into 3 layers into 25 number of blows divided by 1000. Correct? Then what is your answer? This is your 5.81. The answer is 5.81. Very interestingly, if I do this calculation for the other one, here, look at here, this the hammer is 2.5 kg, drop is 31 centimeter, layers is 3, blows is 56, divided by 2250. Then the answer is how much? 5.78. 5.78 rounded to 5.8. Then this is also 5.8. Now look at here. We have not done any wrong by choosing these specifications, because light compaction means 5.8 energy. Light compaction means 5.8 energy. Like that, when you come this side, that is a heavy compaction. Then the heavy compaction means, how you calculate? This is your 4.5 kg, 45 centimeter, 5 layers, 25 blows divided by 1000. What is the answer? 25.3, 25.31. Right? Then the same answer we have to get here. 4.5 kg, 45 centimeter, 5 layers, 56 blows divided by 2250. The answer you have to get it here same. 4.5, 45, 5,
The 25.2.
correct? 56 divided by
Yes, sir.
2250. Means here also you are getting 25.2 something. Now see, the heavy compaction means what? 25.3 or something near to that one. Means you come to know that heavy compaction is heavier, light compaction is lighter. How many times heavy compaction is heavier? Approximately 5 times heavier. 5.8 and this is 2.5. 25 means 5 times, approximately 5 times heavier than the light compaction. This is very important question. Many times they will ask, heavy compaction how many times heavier? 5 times it is heavier. Understood? 5, remember here, 5 times heavier means 5 times heavier means approximately 400% heavier. Always you have to minus 1 and give the answer. See, when I multiply 1.5 times, 1.5 times means what? This is 50% more. When I say 1.8%, 1.8 times, then this is 80%. Like that, when I multiply 5 times, then I have to say it is 400%. This heavy compaction is 400% more than the light compaction. Okay, this one you have to remember. Over. This is the compaction chapter. No? But after this also we have to study some graphs. I have to study. I will come back to the original rough notebook. Any doubt here? Because I am going to stop this presentation and start the new one. Do you have any doubt here? Okay. We'll go ahead. Now look at here. What is the effect of this heavy compaction and low compaction in the graph? If I see in the graph, what happens? So now, see here. Initially, your graph will be like this, because as you increase the water content, this is your water content, and this is your density, dry density. As you increase the dry density, water content, dry density will increase. Dry density will increase. Then after that, when it reaches the optimum, maximum dry density, this is your MDD, and at that point the water content is considered as a OMC. Correct? Now if you do heavy compaction for the same soil, what happens? Then the curve will shift this side. The curve will shift this side means then the OMC decreases and density increases. They may ask you, this is your light compaction, and this is your heavy compaction. Okay, na? A standard Proctor test, and this is your modified Proctor test. Then what is the effect of standard Proctor test? Modified Proctor test antandre, then OMC will decrease, then density will increase. This is the effect. Understood? Okay. For the same soil. The application of this light compaction is your general roads. Even you can go up to SH, national highways. Even some extent they will go for NH also, this light compaction. But heavy compaction we have to do it for runways, and this one expressways. Expressways are very important buildings. There below the buildings, there you will do this heavy modified or heavy compaction. This is your light compaction. Understood?
ಸರ್
Hmm.
ಸರ್ ಇನ್ನೊಂದ್ಸಲ ತಿಳಿಸ್ತೀರಿ ಸರ್ ವಿಡಿಯೋ ಸ್ಟ್ರಕ್ಟ್ ಆಗಿತ್ತು ಸರ್ ನಿಮ್ದು ಇದೆ ಸರ್ ಗ್ರಾಫ್
Graph.
ಹಾಂ ಸರ್
Okay.
ಹಾಂ ಸರ್
Okay. Here the initially we know that this is a water content and this is the dry density, right? Then initially, as you increase the water content, then dry density will increase and it will reach at a maximum. It will reach a maximum density, that is called as MDD, maximum dry density, and corresponding water content is called as the optimum moisture content. Then if you increase the water more than optimum moisture content, then the density will decrease. Okay, this effect where you are seeing, this effect you are seeing in a light compaction. Okay, now the same soil, see this soil is done with a light compaction, and the same soil if you do another test, then you do it for heavy compaction, then you will get a curve shifted towards rightwards, leftwards, and upwards. Okay, from this what you can observe is, what you can observe here is this OMC is reduced. Okay, means for a small water content you are getting a more density, the density is increased and OMC is decreased. Let us consider light compaction where you are getting a 1.8 gram per cc as a density. 1.8 you are getting at 25% of water. Let us consider this is an example, right? 1.8 you are getting in 25% of water. Now if I do heavy compaction, then you can achieve 2.2 kg, that what gram per cc, more density in less water content. How much it might be? About 15%. Means by adding only 15% you are getting a more. Why? Because effort is more. Compaction effort is bigger in the heavy compaction. Understood? Any doubts here? No doubt? Okay. Now we have one more concept here that you might be getting one doubt here. Whatever that is, light compaction or heavy compaction. The light compaction or heavy compaction, your graph is something like this. This is called as a maximum dry density, MDD, and the corresponding water content is your OMC, that is optimum moisture content. Now if I consider one particular point other than this optimum point, if I consider this point, means I will give some value so that you can understand. Let us consider this is your 1.8, and below that 1.8 means this is your 1.5, and this one I will give a 25%, and 1.5 density you can achieve at 20%. Let us consider 20%. Means here 20% water you are adding and your density is 1.5. Then 25% water you are adding, then your density is 1.8. Increase, no? Your water increased and therefore density increased. Then thinking the same way, if you increase further, then if you make 30% of water, then again density will be, sorry, my graph is something not good. Don't worry. If I increase 30% of water, then I may get again same, again I may get 1.5. Here one very interesting thing is there. 20% water you add, density is same. 30% water you add, then the density is same. Right? Whether it is interesting or not. Therefore, we will divide this entire graph into two phases. This phase I will call it as a lower than the optimum moisture content. This is I will consider it as a dry side, and this is I will consider it as a wet side. This is dry of the optimum, dry side of the optimum. This is considered as a wet of the optimum. Understood? Here what happens? Density will be same. Density is same in the dry and wet side, but there are some other properties they will be changing. Those property we have to discuss now. This is considered as a effect of compaction on soil property. Effect of compaction on soil property. Okay, now I will divide this entire page into two parts, and this is your property. Let us discuss on soil structure. Okay, soil structure means we have a four type of soil structure. This I didn't explain because it was not included in this syllabus, but you have to go through that one. We have a four type of soil structure. The first one is a single grain soil structure, and honeycomb soil structure, and flocculated soil structure, and a soil structure. Dispersed soil structure. Single grained and honeycomb soil structures belongs to sand and gravel. Sand and gravel. A honeycomb may be with a little of silt, but when you come to the flocculated and dispersed structure, both are of the same soil, but their nature is different. Both belongs to clay soil. Okay. Now I am discussing about the soil structure. Dry of the optimum. If you see any particular soil, there will be a flocculated soil structure. This is called as a flocculated soil structure. When you come in the wet of the optimum, then that will be dispersed soil structure. Okay, this is flocculated and this is dispersed, but both will have a same density. Very important. Both will have a same density. This is your soil structure. Then we have another property, that is a permeability. The second property is permeability. Can anyone tell me permeability is more in dry side or a wet side? Permeability is more in dry side or wet side?
Wet side.
Wet side?
Dry side.
Dry side?
Dry side.
Can you justify?
Um,
Hmm? The answer is dry side more will be there and wet side less will be there. The answer is just here in the slide only. See here, flocculated structure means you can see the some voids more here. Therefore, water will pass very easily. Because soil structure is flocculated, then here dispersed soil structure means one layer, one clay particle over another clay particle. Therefore, the space will be very less here. Therefore, less permeability. Then the next one will come shrinkage. Now, can you guess? Shrinkage will be more in dry side or wet side?
So wet side.
wet side.
Wet side more?
Yes.
Correct answer. Wet side we will be having a more shrinkage than the dry side. Why? Because dry side shrinkage property is always with respect to water. Therefore,
Water percentage.
dry side means less water. Therefore, less shrinkage. Wet side more water, more shrinkage we can consider. Then we have a swelling. We have a swelling. Shrinkage and swelling is completely opposite to each other. Directly we can give here, that is more swelling dry side and less swelling in the wet side. But it is very, this one no, it's not able to digest, because you don't think like I am adding water therefore it is swelling. No, For a particular water content, you have to think. For when the soil is dry with a small moisture content, then it can swell more. For a particular water content, think about this 20% water content. At a 20% water content, the soil will swell more. But at a 30% of water content, the soil will swell less. Then don't compare like 20 and 30. Don't say like, sir, 20% means this was swelled this much, and 30% means obviously it will swell more. Yes, obviously it will swell more, but dry of the optimum. Compare this 30 only with some other soils with 30. Then you can say that the swelling effect will be more in the 30, or you can consider it as swelling pressure. You write it, then you can digest this one. Swelling pressure here and swelling pressure here. Understood? Next one will be pore pressure. Pore pressure more where?
Wet side.
Wet side, more pore pressure, correct answer. Pore pressure will be more here, and this is very less here. Sometimes pore pressure is zero, I can consider here. Why? Because these pores are not completely filled by water, therefore there won't be any pore pressure, or less pore pressure. This is less pore pressure. Then this one is more pore pressure. Then the next one is the compressibility. Which will compress more?
Dry side.
Dry side?
Yes.
Wet side of the soil will be more compressible. Why? Because the water is there. When you apply the load, the water will escape easily. Therefore, the soil will be compressed. Okay. Therefore, here more compressibility will be there. Then dry side, here what that has to escape? Okay, even though air can escape and air can compress, but volume will be somewhat same only, no? Little decrement will be there. But when water comes, then only you can see a large amount of volume reduction. Therefore, here dry of the optimum, you will be having less compressible, and wet of the optimum you will be having more compressibility. Then can you tell me the shear strength? Where shear strength will be more?
Dry side.
Very good. Dry side shear strength will be more because because water acts as a lubricant here. This is one particle, this is another particle. Then if you consider a water, then the water acts as a lubrication here. Therefore, here strength will be less. Strength will be less here. Okay, then the strength will be more here. Dry side, more strength will be there. Understood? These are the properties which are affected by compaction. By doing compaction, these properties will affect in this manner. Okay. Right now, I have completed this compaction. But last one chapter is there. That is your field compaction. Okay. In the field, what we have to do, how we will do the compaction, and that we will be discussing here. One question definitely they may ask here. That's why we have to discuss very keenly. That is, following are the generally used compaction equipments in the field. We have smooth wheeled steel drum rollers, pneumatic tired rollers, sheep foot rollers, impact rollers, vibrating rollers, hard pan or vibrating pan or rammer compactors. See, you can see this one. This is called as a smooth wheeled steel drum. This is a steel drum, or otherwise here steel drum is there. This surface is smooth. The surface is smooth. Therefore, the capacity is 20 kilonewton to 200 kilonewton. It will be having that one. And the self-propelled are towed. Self-propelled means the equipment will be there here. That driver can sit here and you can operate this one. Or towed means you can put with some another tractor you can use and just you can pull this one. Suitable for, this is very important. This point is very important. Suitable for graded sand, gravel, silt for low plasticity. This silt means there are high plasticity silt and low plasticity silt. That is your ML and MH. No? Low plasticity silt and high plasticity silt. but this type of compaction will be for silt with low plasticity only, you know. And gravel and say this one graded they are using means this is well graded, it is there no already. Well graded sand or well graded gravel you can consider. Then the suitable for uniform sand, unsuitable for uniform sand, silty sand, soft clay. Obviously if you read this point perfectly then you can answer this point because this is just opposite to that one. Understood? Next one is pneumatic tired rollers. Here we have a tires here, right? Here we have a tires here. Why it is called as a pneumatic? Because it will be pressing and rolling. See here, the earlier one it is just rolling, it is just rolling, no, it is just rolling. But here what happens, this one, this will press and roll, press plus roll. Okay, na? That is called as a pneumatic. Then usually two axles carrying rubber tired wheels for full width of track. Then this will have a weight of 100 to 400 kilonewton, very heavy, suitable for most coarse and fine soils. Okay, both. This is suitable for even coarse soil also and fine soils also. Unsuitable for very soft clay and highly variable soils. This is unsuitable for very soft clay. Instead of, then comes sheep-footed roller. Sheep-footed roller. Sheep means that bakra, no? That sheep will be there. That here you will be seeing some projections on the wheel. No? These projections are there. Those projections they are using. The weight is 50 kilonewton to 80 kilonewton. Suitable for fine grained soil, sand and gravel with considerable fines. Considerable fines. Fine grained soil we can remove this one, most probably we will not use it for fine grained soil. Sand and gravel with considerable fines means a small amount of fines. Small amount of fines you can use this sheep foot roller. Then comes impact roller. Roller you will understand it by seeing the diagram only. This is impact. Why? Because when this vehicle moves forward then this will be falling, this will be suddenly falls on the ground, then the again suddenly fall on the ground, again sudden fall on the ground, therefore it is called as a impact roller. Then compaction by static pressure combined with impact, both will be there, no, because when it is there here it is giving static and impact pressure, both it is giving by pentagonal rollers. Not only pentagon, you can use hexagon also depending on the site. High compaction energy breaks the soil lumps. It is used to break the soil lumps and provides kneading action. Kneading action means you can consider it as again like pressing and forwarding, pressing and forwarding. Okay. Then comes vibrating roller. Vibrating roller, most of you might be seen in while highway projects. Roller drum fitted with a vibratory motion. Inside the motion, vibrations will be there. Leveled levels and smoother nuts. Okay, the nuts will be smooth and don't run. Then the last one is a hand operated. This one not explained. No, suitability. Suitability of vibration is sand soil, sandy soil. Even you can consider uniformly graded sand also you can compact it by vibration. Then hand operated vibrating plate. See here, this will be a plate and there is a machine here that will operate this one. It is used for backfilled trenches, smaller constructions and less accessible locations. There you can use it. Okay, which type of material? Any material you can use it for hand operated. Okay, now this is all about field compaction tests methods, right? Over. Any doubt? Compaction chapter completes here. Do you have any doubts? No doubt. Okay, we'll take a 5 or 6 minutes break, then we'll come back.